Hello friends, let us now learn some important points about the cathode in the production of X-rays. So in the last class we have learned about the glass enclosure in the production of X-rays. Now let us learn some important points about the cathode. So cathode is actually made up of filament. The filament is actually tungsten. Okay. So we are connecting the cathode and the anode to a potential difference and to the current. So we are connecting it to a current or electricity. So any electricity will have current and the voltage. So the current should be around 3 to 5 angstroms and the voltage should be around 10 volts. So when the current is around 3 to 5 angstroms and voltage is across 10 volts, then the electricity passes to the cathode. The cathode will get heated. When the cathode is heated, so the electrons are released from the cathode and they hit the anode, and when they hit the anode, the X-rays are produced. Okay, so the flow of electrons is nothing but current, right? What do we call it as current? Current is flow of electrons. So this is the current of external, like outside. The current which you give outside is this current. When the electron flows from the cathode to anode, this flow of electrons from cathode to anode will give tube current. So when the flow of electrons from cathode to anode, we get tube current. So this tube current is measured in milliamperes. So milliamperes is actually the tube current, which is the current in the X-ray tube. So this milliampere will be 1 milliampere is actually 0.001 angstroms. Okay, this 3 to 5 angstroms is the current at the cathode, which is giving electricity to the cathode. So when we increase the current here, the cathode is heated more. So more electrons are generated. That means there is increased tube current. That means more X-rays are produced. So the amount of X-rays and the energy of X-rays produced is directly dependent upon the current which we give to the cathode. So we are heating the cathode. So when the current electricity is applied, so cathode is heated. Okay. So what is this cathode made up of? This cathode is actually made up of a tungsten. That tungsten has a diameter of 0.2 mm. Okay. Cathode is actually made up of a long wire which is of tungsten, and this tungsten has a diameter of 0.2 millimeters. Okay. This long wire is wound into this into a spiral form. So this long wire is wounded into this spiral form uh, in such a way that this filament is actually 1 centimeter in length and 0.2 centimeters in width. Now, when this current is passed, this cathode is heated. So when this cathode is heated, the cathode actually contains atoms, right? Every element or every element or every material, each and every material will contain atoms. So cathode also contains atoms. So when you are heating the uh, filament, so the filament gets heated. That means the atoms are heated. So when the atoms are heated, what will happen? So we'll see. See, when we are giving current to the cathode, that means the cathode is heated. So when the cathode is heated, this is an atom. Atom will contain a nucleus and it contains electrons. So when this cathode is heated, the atom also is heated. So when this atom is heated meaning the thermal energy, right? Heated is nothing but thermal energy. So with the help of this thermal energy is given to the electron, that is outermost shell electron, and this electron will leave the orbit. So when the electron leaves the orbit, it will travel a small amount of distance in front of the cathode. See, the electron initially it can't go into the anode because it needs lot of energy to overcome this, and it has to go to the anode. So it needs lot of energy. So electron cannot directly go to the anode. So as a result, first it comes out of its orbit and the electrons will start accumulating around the cathode. So this is the cathode. First one electron has come, next one electron. So all the electrons are accumulated around the cathode. So when the electrons are accumulated around the cathode, so all of this is negative charge. Okay. So these electrons which are accumulated in the cathode, at the cathode, this is called as space charge. or electron cloud. So when the atom is heated, the electrons are released from the nucleus, and these electrons will travel a certain amount of distance in front of the cathode, and these electrons are accumulated in front of cathode. So the electrons which are accumulated in front of cathode is called as electron cloud or space charge. So when a new electron is coming out of the atom, so this electron cloud will prevent the new electron from accelerating towards the anode. Okay, so this space charge or electron cloud will prevent the new electron from accelerating towards the anode. So this is called as space charge effect. Okay, so this cathode is made up of an element called as tungsten, which we have already seen. So this tungsten, why is it made up of tungsten? Why do we have to use tungsten? The reason is this tungsten, when heated to 2200 degrees Celsius, it emits electrons. So our aim is to heat this tungsten filament to 2200 degrees Celsius for an electron to emit. So the melting point of this tungsten should be more than that of 2200 degrees Celsius, because if it melts even before it emits electron, so obviously it is not needed. So tungsten has a high melting point of 3370 degrees Celsius, and this tungsten is a very thin wire and it is very strong because of its strength, because of its high melting point, and because it can emit electrons. So tungsten is used as an is used for making cathodes. Okay, so when we heat, that is when we give thermal energy, this electron is released. So this process of releasing electron when it is heated is called as thermionic emission. So the process where electron is released when heated is called as thermionic emission. Now, so when the filament is heated, okay, the filament contains an atom. So when the filament is heated, the heat energy or thermal energy is transferred to the atom and the electron is released. When this electron, there are lot of electrons around it, so there is an electron cloud around it which prevents the electron to go out. But when it is heated, so generally it starts from 0 degrees and it gets heated to 2200 degrees Celsius. When it is heated to 2200 degrees Celsius, the electron will emit and it can overcome this space charge effect and it starts accelerating towards the anode. So, when the electron is heated, when the filament is heated to 2200 degrees Celsius, the electron gains sufficient energy to overcome this space charge effect and the electron is accelerated towards the anode. So when the electron is accelerated towards the anode, so this is anode. So now the electron has reached the anode. That means the atom has lost an electron. So when an atom has lost an electron, it acquires a positive charge. So when it acquires a positive charge, around it the electrons are negatively charged, right? So one of the electron will, from this space charge effect, will occupy the position of this lost electron. So in this way, the electrons are produced from the cathode will reach the anode. Now, when there is a cathode, when this is cathode, this is anode, the electrons can travel in different directions. It can go like this, it can go like this, like this, like this, like this, can go like this, it can go like this. See, there are the electron can go in multiple directions, right? So when it goes to this level, these electrons are useful, whereas these electrons will actually hit the glass instead of the anode. When the electrons hit the anode, the X-rays are produced. If the electrons hit the anode, X-rays are produced. But if the electron hits the glass tube, these are not desired, right? These are lost. These electrons will not produce X-rays. So as a result, our aim is to make sure that each and every electron that is accelerated, it should hit the anode. So all electrons which are accelerated should actually hit the anode. Only then the purpose of the X-ray tube is served. So as a result, we have made a new modification in the cathode, which is called as focusing cup. So this is the focusing cup. Okay, and inside the focusing cup, the cathode is placed. Inside the focusing cup, cathode is placed. So this is cathode and this is the focusing cup. So now, because of this focusing cup, each and every electron that is produced will travel like this. Okay, so this focusing cup will allow the electrons to directly focus onto the anode. So all the electrons which are produced by the cathode will reach the anode and they will not reach the glass tube. That is, majority of electrons will reach the anode. So this focusing cup is actually made up of a metal called as nickel. This is nickel. So the focusing cup is actually made up of nickel. Focusing cup can also be made up of molybdenum, and this molybdenum has higher melting point and it has good thermionic emitters, but mostly it is actually made up of nickel. So we have learnt about the cathode. So cathode is nothing but the filament. Okay, so in the normal X-ray tube which we use, the cathode is only single filament. Okay, but there are also few X-ray tubes where there can be double filament and triple filament. These are actually used in angiographies. In angiographies, that is in fluoroscopy, we can use a double filament and triple filament X-ray tubes. So we have learned about how the electrons are produced. Now the problems in electron generation, or we'll see what problems do we have in the cathode, at the cathode level. So when we heat, so when an electricity is passed, so the electrons will travel from into to the cathode. So when the electrons travel to the cathode, so this whole circuit is heated, so this filament is also heated. So when the filament is heated, so remember, if any metal is heated, it will get evaporated. Okay. So if you heat water, so there is a bucket of water, and if you heat it, obviously it gets evaporated into some vapor, right? Water vapor. So even the metal also, at certain point, it will start evaporating. So the tungsten filament will start evaporating. When the tungsten filament starts evaporating, this tungsten filament will evaporate and it will start moving towards the glass tube. And the tungsten filament will accumulate on the glass tube like this. So when the tungsten filament accumulates in the glass tube, because glass is actually a normal glass, right? So it is transparent. Whereas tungsten has actually metal, metal color like steel, iron, the color which we have in the metal. So that color is there for the tungsten. So when the tungsten filaments are evaporated and when they coat or when they attach to the Pyrex glass, so the glass will turn into bronze colored, and this is called as bronze colored sunburn or aging of the tube. So when the tungsten filament gets evaporated and the molecules of tungsten or atoms of tungsten, when they attach to the glass enclosure, and this tungsten attaching to the glass enclosure will turn the tube color to bronze colored. So this is called as bronze colored sunburn or aging of the tube. Okay, so what happens? So if when the electrons will hit the anode, X-rays are produced. These X-rays which are produced, okay, these X-rays will have to travel through this tungsten coating and they should come out to reach the patient. Okay, so this some of the X-rays are lost in the tungsten coating itself. So this is not desirable. Okay, so the how do we prevent this tungsten vaporization or aging tube or bronze colored sunburn? This is by making the tungsten filament as thin as possible so that it can resist the vaporization. Okay, then there is also something called as automatic film boosting circuit. This I think the radiographers will know better about this. So before we switch on the tube, there is a before we switch on the X-ray tube, we will keep the X-ray tube in standby position. There is a switch called as standby. This standby standby. So this standby will actually give some uh, current to the filament. A small amount of current is given to the filament. So when a small amount of current is given to the filament and it is heated a little, and when you actually press the actual button for X-ray generation, then electrons are released. Then the electricity which is sufficient to accelerate the electrons is released. So this standby button will preheat the X-ray tube a little, and this is called as automatic film boosting circuit. So this will prevent the X-ray. So this standby current will actually heat the filament to a low current, and that is around 5 milliamperes. 5 milliamperes is given to the X-ray tube, and this is heated to a 5 milliampere. So this small amount of heating will raise the filament current, and it will help in further actual exposure when it is made. So this process where we keep the standby current is called as automatic film boosting circuit. So this is about the cathode. In the next class we will learn about the line focus principle. Thank you.